has moved faster.
Thank you, Professor Paulraj. And then, so when you see across, like the low, mid, and high band, almost like technologies, and so the business, the growth, and what do you feel are the key drivers across these? Are they three separate markets that would kind of grow at their own pace in their own directions, or is there like overlaps between them?
Yeah, thank you. That's a good question. Um, um, Certainly, the millimetric band is a bit of an animal by itself because it's uh, uh, it has a lot of challenges in propagation. Uh, and certainly, partly the range should not be a challenge fundamentally because if you have enough antenna aperture, long fill it up with lots of dipoles, you should be able to capture the photons. You should be okay. But the problem, of course, is also the problem of shadowing. So anything shadows these links. So coverage is a problem, and but it does lots of capacity. So uh, so I would say that this band and and probably because of the coverage issues, it's probably going to be used largely in outdoors pedestrian access and potentially indoors in enterprises, human enterprises, where you could, just like LTE, for example, is pretty, enterprise LTE is pretty large. 5G, millimetric band LTE is also, 5G will become, I think, large. Um, uh, and But I think the experience of the last year and a half might say that uh, uh, the next spurt of growth really will be in the mid band, and millimetric band will stay a little low in growth till I think mid band fills up. So that I think is probably U.S. wisdom right now. Uh, China, the other big player, doesn't talk much about millimetric band, but I suspect they will look at it soon. Um, the midband, which really is probably all the way from 1,000 gigahertz up to 6 gigahertz. There, much of the activity has been for 5G around is three from 3.3 or 3.2 all the way to about 4.0, where different countries have different allocations. This band is interesting because, first of all, it has a lot of spectrum. For example, US is deployed now allocated 3.7 to 4.0 or 3.98, almost 300 megahertz. China has 300 megahertz lower down, 3.3 to 3.6. So lots of spectrum available. It's not too far from the band 41, which is the 2.5 band we already use all over the world, heavily in this country by Sprint, T-Mobile, and therefore the spectrum, the coverage is sort of fairly well understood. It has challenges, but not terrible, and lots of spectrum, and you can sustain with 100 megahertz channelization, 1 gigabit type links. So this band is, I think, is going to be it's already very strong in China, and I think it'll develop very strongly in the United States and elsewhere in the world. The low bands are fundamentally not new bands, just reformed from 4G to 5G. And eventually, I think by in half a dozen years, half the spectrum occupancy of these low bands will be by 5G now. Already in US, we do have a mode of deployment called dynamic spectrum sharing, where we actually in a given allocation run partly 4G and partly 5G. So that's begun to happen, but 5G will take over slowly much of 4G. So I would say the low bands right now there's probably no 5G there at all, or there may be very little. Mid band is where the much of the action is, but US has no catch up. And the millimetric band, I think, might turn out to be a bit of a slowing now, and probably around 24 to 3 years it might pick up.
Thank you for those insights. So I mean, as these new technologies are being introduced, and this happened, when Bluetooth was being introduced, coexistence is a common issue. And as they operate in co-located frequency bands with neighbor legacy communications. So what is this issue that has come up recently with the recent FAA related pause on the 5G rollout in the US, and is it expected to be a significant hurdle as the race has started now in full speed?
Right? It's surprising that we this got came up so late in the game. These bans have been. This is the problem. Fundamentally, is the aviation altimeter above ground altitude above ground AGL, I think altimeter uses FMCW radar. It operates at 4.2 to 4.4 gigahertz, 200 megahertz wide, and this is came into aircrafts in commercial jets. I think around 1980s. It's was spec at that time, and it's critical for operations for the kind of what is called as category 3 landings, or almost blind landings. It was also critical for helicopters, for medvac helicopters, like ones which fly by my house here for the Stanford Hospital. So a lot of helicopters land in urban areas require this altimeters also, as well as general aviation. It turns out that this the the receiver mask for these systems were defined 30, 40 years ago. So they were very relaxed. So they fell off so slowly that even at from the 3.8, 3.7 to the 4 gigahertz area where 5G now is operating in the United States, the receiver mask is not able to detect the transmissions properly. So even though the 4G band is 200 megahertz below the radar band, it is still leaking in. We are leaking in into the 5G is leaking into there because of the receiver mask, and it's not going to be possible to change everything quickly. So this has been a somehow this came up only a few months ago. It was noticed by the FAA, and so there's been quite a bit controversy. I think White House got involved, and finally there's been a compromise. So 5G will be now operated in the mid band at a lower uh, power levels. I think there's some negotiations being done in several cities, and particularly near airports, it will be either not be operated or be much lower, even lower power. So there's some compromise come out to try and handle this problem in the United States. Now, and of course, this can't go on forever, so there might be some more compromise where we will have to, the 5G people have to fund the aviation people to change the technology and so on and so forth. But it's going to take time. In aviation, everything takes time. So that's the problem in US. But countries which actually have stuff happening from 3.7, 3.8 to 4 gigahertz band, there are other countries and they will have problems. I think France also has a similar problem. China operates in the 3.3 to 3.6 band, and they don't seem to have a problem. Lower down. India, I think, is also India. Of course, I'm not sure we allocated spectrum formally, but I think it's also low. So this seems to be a pretty much largely a US problem, and not entirely resolved. It's resolved by 5G backing down, uh, but uh, but I think there's going to be much more happening here because the operators here have paid almost $90 billion for the spectrum. So obviously they are upset, and it's very strange that there was a lot of discussion about this ban, and the satellite people with incumbents, they were moved out. A compensation was paid to them. It was in Congress in bills, but this thing came up very recently, and it's unfortunate.
Yeah, it's surprising that it's they just woke up to this right now. But yeah, thank you. I think this will be one of these questions on how this modification will allow the kind of specialized hardware or constraints just in certain markets and how it scales. But I'll pass it over to the other chairs, and I think there's a general audience question in the background. I'll just post it. I don't want to take up more time, but that is more on, like, where would students want to do their research. But I think that's a common question for all the chairs, but we can
Sure.
move
Yeah,
on to the next chair. Thank you so
yeah,
much.
I agree. I think we'll take more Q&A from the audience towards the end as well. So thank you so much, Rahul. So next we'll move on to Rajesh from SMU, Professor Rajesh Balan, who will talk about the rest of Asia perspective.
Hello, Professor Poraj. Thank you for this great answers to the questions about the US. So, looking more at Asia and China in particular, I think one question that I would love to get your insight on is what made China so different in that they were so quick to rush to 5G? Because I'm from Singapore, and in Singapore, at least the telcos, when I talk to them, tell me, look, they've invested a lot of money in LTE and 4G, and they're still trying to recoup that investment. So they're not in any big hurry to switch to a whole new radio network. So what made China particularly different in this sense?
Right. I wish I had a good answer, but I can try and attempt an answer. For one thing is that I think the realization that 5G could be transformative uh, in terms of digitalization, Industry 4.0. That realization was very strong high up in the government, right up to the president of China. So obviously, a lot of resources and focus came there. They picked the right band. They decided to go with mid band, which I think was also the right, turned out to be the right choice. Millimetric band, like happened in the US, would have slowed them down. And I think the other thing about China is, of course, all the carriers are, some of them are state-owned, CMCC and others, but they tend to be cash rich because the business model seem to be working well in China. Uh, and Chinese government, though I doubt they would support the carriers directly financially, they certainly have created large, not city scale, but suburban level test beds for trying out, intelligent vehicles and MMTC. So they have done a lot of test beds to create 5G type testing, which is also, I think, has therefore pulled up the carriers to address these new areas. In fact, the thing in the United States, which is not done well so far, is that we are still talking only about EMBB as higher speed access to phones. We really haven't pushed strongly into IoT, MMTC, and ultra reliable low latency applications. China has moved faster there. There, I think government has spent money in creating test beds, and
Right.
so I think the ability to, I think, availability of financial resources, the ability of government to write checks, and I think a general political level decision to focus on this technology added to this. U.S., of course, I think the spectrum is proved to be pretty expensive. So that's usually a problem with many of the countries with auction spectrum. And the other point of this, I think the millimetric band was probably in hindsight could be done differently. I think.
Okay, thank you. So a combination of top-down vision, lots of money, and the political willpower to get everything done. Okay. I had a related question to that actually, right? Because I looked at 2G, 3G, 4G, and a lot of the technical innovation, a lot of the thought leadership was all coming out of the US for those things. But 5G is different. China is actually has become something of a global leader in this space, both in terms of technology, in terms of outputs, etc. What can you share about how did this manage to happen, and what can we learn from this moving forward?
Right. It's true. I think uh, China, has Huawei and ZTE or CICT now, I think, have strong products in 5G and I think mature. I, the other people who have products, of course, are Samsung, Nokia, and Ericsson. I really can't compare them across to see how they differentiate against each other. But China has very credible products, and and of course, in terms of IP coverage, they have. I think China Huawei has probably, in terms of numerically, the largest number of patent families. So ZT is pretty strong too. So they have been very active in the standards and have lots of IP in the standards. But one could argue, and I think that's what U.S. government is now argues also, is that a lot of the fundamental ideas behind cellular, from the idea of cellular and handover to CDMA to OFDM to MIMO, all these came from the United States largely. I mean, one can argue CDMA, there was a lot of it done in Japan and Europe too. But converting that into products has been slow. Today, for example, um, uh, there is no U.S. company, U.S. headquartered company, which has strong products in 5G. Um, uh, uh, Today, Verizon and AT&T deploy Samsung and maybe Ericsson and some Nokia, I think. But there's no U.S. companies as yet in the mix. The U.S. approach, company approach, has been to go with this idea of ORAN, where we partition the RAN of 5G RAN into different boxes. All of you know about it: RU, DU, and CU, and build open interfaces and create more competition. These are good ideas, but 5G is a very complex air interface. It's much more complex than 4G because of the issue of beamforming. That adds a dimensionality which is not there in 4G, as well as 5G interface is very flexible. Almost any parameter you touch is kind of programmable with the flexible numerology and TDD and so many other things. So taking such a complex interface, dividing it up, getting small companies to do individual pieces and come together turned out to be very slow. So I think the paths to infrastructure, of course, US still dominates in the client side because Apple phones and Qualcomm chipsets have delivered the client side phones. Of course, Samsung also has very good devices. But on infrastructure, I think the path that US took of going with kind of the ORAN type architecture has slowed us down. So China, of course, is still its Huawei and ZTE and CICT who are doing this stuff. So they seem to have taken a different path, which has worked out faster for them. But I do think that ORAN is eventually the right idea if we can sort out all the issues, and that will enable the more competition and better technology. But it hasn't happened as yet.
Okay, thank you.
Okay, thank you.
Raj.
Right.
I had a
I
last
had a last.
I'm hearing echo. I had a last question about what types of deployments we believe will be practical for 5G, given there's so many different use cases. You read release 15, 16, 17, 18, but I'll hold off on that because I'm sure that will come up later in the other questions as well. So I'll pass back to the chairs to move on to the next person asking questions.
Sure.
Next, we have Satish Chamatagni from RIL, who's going to ask questions about 5G from the Indian perspective, operator's perspective.
Yeah, thank you. Professor, one of the, you must be aware that Reliance Jio is attempting to do 5G equipment. We have investments into a company called Radisys, and we're trying to do our own equipment. One of the key things that we're trying to face is issues related to the size of the massive MIMO panels, the weight of the RUs which actually go on the tower, because these are factors which will contribute substantially to the cost of the overall deployment. And the heat. One of the key things that we are trying to play around with is the materials, which is very different from the conventional one, both for the power amplifiers like complex semiconductors and heat sinks as well, nanomaterials for heat sinks. Are you hearing progress in this direction in the rest of the world? Is it something that's getting a lot of traction? Because just to give you an example, a 32 T32R massive MIMO RU, which actually goes on the tower, weighs something around 30-35 kilograms. It used to be 50, but it's come down to 30-35. But then most of the tier one vendors still talk of sub 20 kilograms. Still, it's 4x, 5x of what LTE 44R panels are. That means one has to really rejig the complete the real estate and the towers. And today there's a lot of sharing of towers, which is not possible in the case of 5G because the weight issue. But is this something that is seen as a concern in the rest of the world?
Right. Uh, I have some connections with the RF side of 5G. With large number of antenna arrays, 32 by 32, and so on and so forth. The I have to, this hasn't been flagged. The issue, of course, there's always the issue of cost, and the other issue is that because the normal partitioning, I think you have a different architecture where you just have the RU, at least have the RRU on top, and have the rest of the BBU type approach down below. Uh, but I'm more familiar with the ORAN architecture, where, as you know, it is difficult to do a pure RU DU split, and we have this hybrid 7.2 splits and so on and so forth. So the thing that gets flagged often in this whole in 5G infrastructure is usually the processing issues. Obviously, uh, first of all, the split, I think split 6 doesn't really work because it's just too much transport of data. So 7.2 type splits tend to be more popular. And when you go into in that kind of split, the question is also the question of processing. So people use FPGAs, which are expensive, and there's been a lot of drive towards ASICs. So I've seen a lot of activity around the processing part of the 5G DU, RU-DU area. And I've not seen, I do know that there are power and power dissipation issues. I haven't seen it come up as a front and center but on the other hand, I've not really delved deeply into these things. I'm kind of familiar with some relay company building relays, which also have to have antenna arrays, and so I've not seen this flagged as yet, Satish. And of course, India, of course, it's also true around the world. We do have a higher ambient temperature, and so that may be an additional concern for us, the sun load and all that.
Yes, thank you. Because this is one of the key problems that we are trying to address. The other question is with respect to the backhaul, fiber penetration to really support the kind of applications that 5G is expected to support. In India, of course, this is an ongoing process. It's still a lot to be covered. But is that the same case elsewhere? Because they've gone ahead and put in the towers, yes, but the fiber.
Right. You know, backhaul is a problem certainly in the United States. I wouldn't know much about elsewhere, but in LT, typically it is you would run fiber to one tower and then do a radio link to neighboring 4 or 5 towers. I think with millimetric band, you have to pull fiber to each tower, and and it's like, and that's part of the cost. So today, actually, a cost of setting up a millimetric band base station is about $80,000. It's the cost of pulling a fiber in, apparently, assuming it's available nearby, is about $7,000, maybe more. And the city permits, and then with the cost of electronics, is probably about 25,000. And antenna arrays, which are the 3-sector antennas, massive MIMO arrays on top, and the pole, it all adds up to about $70,000. a lot of money, and fiber's something like 10% of that cost. Uh, and of course, if it's only a fiber feeding this at the is only pulling between DU and CU, it's not very heavy, and it's not so. I think a standard fiber will do it. But if you're splitting it differently, where your RU is only the RU is sitting on the pole and the DU is elsewhere, then of course the load is much larger, and I think fibers. I mean, the fiber links will be much more onerous. You probably need 50, 60 gigabits per second. So uh, yeah, so I don't, I I don't think even in the mid bands we can get away with this fiber to this in the, to the center serving base station and then use radio links. You probably need fiber everywhere, and it's expensive. So US has this challenge of pushing in fiber.
Okay, one
India, I
last.
think, should be easier in my opinion because now it may be more difficult, but I think 15, 20 years ago, you could trench cities much easier.
Yes, that's one of the key things that we're facing right now. One of the last questions, Professor, from my side for India is what in your view would be the right use cases for India? Because we have, of course, as an operator, we have our view of what would be the first few use cases, and subsequently, of course, the use cases would build in. But
Right.
your views.
So, there was a report written by the government. I was the chair of the steering committee and wrote the report 2017, 2018, I think it was. And one thing that report was mostly about deployment issues, challenges, all the many things that can be done at both government and non-governmental levels to push deployment forward. And I think the report made a point saying that as far as the kind of high-speed service to phones, that's the easiest part to happen because people will realize the value of high-speed links and will change their phones and become 5G subscribers. But much more valuable for India because of the fact that we have poor infrastructure would be the other two aspects of 5G, the ultra reliable, low latency, and the IoT. And this is something we should embrace much more, embrace a lot. And these are difficult applications to drive because there's, unlike the phones, these industries, the wireless is new to them, and there's a lot of resistance from various viewpoints. So it's an area which is also US is struggling with. And I thought India should really drive uh, the other two aspects of 5G uh, and in a way to to create a virtual infrastructure for us quickly. Um, and of course, India is already doing well in digitalizations over the internet platforms, and lots of companies. But we also need to touch machines and vehicles and buildings. And I think that will be, in my opinion, a huge value for India because particularly because India comes from a weak infrastructure viewpoint, and that's not going to change easily. Infrastructure in our cities is going to be very expensive to do, and 5G could be a big factor there. So I hope we go back to that report and follow through, which also means the government must fund some of these things. Yeah, I agree. I think there's a yeah, I think the G part will happen, but the non-G part is where I think the big payoffs will be there for India.
Thank you, Professor.
And also, I would say that one more point is India hasn't allocated a lot of spectrum for the in 4G, and uh, uh, and I think hopefully in 5G we will be more generous, give more spectrum. So 5G may be another way of getting more spectrum into the system, which I think India really needs. So that could be also, I think, a big factor for Geo because all of us in 4G are very spectrum starved.
Yes, we are looking forward to the 3.5 gigahertz in India spectrum, but we're also fighting on the 6 gigahertz spectrum because there is IMT bands in the 6 gigahertz there is coexistence studies that we're trying to do with ISRO, so that becomes available as well.
All right.
But
Yeah.
thank you very much, Professor.
Yeah. Thank you, Satish. I think some of those questions we're going to address um, next as well. So thank you for fielding those questions, and thank you, Professor Paul Raj. So next we have Nadeem Akhtar, who from Arista Networks is going to ask questions from the Wi-Fi and licensed perspective as well, and how that works with 5G.
Thanks, Arun. So, Professor Paul Raj, continuing from the last comment you made about limited amount of spectrum being made available in India. So the question is, not India specific, but it has some relevance. So, given we had a lot of hype a few years back about LTE and licensed, didn't really materialize into large scale, LTE deployments in 5 gigahertz bands. So, do you see the situation changing with 6 gigahertz being available in US and most other parts of the world, in respect to doing public-private 5G deployments in this particular band, in the 6 gigahertz band?
Yeah. So I think the question, one of course, I think is about private networks and relevance of private networks in the CBRS band, right? Is that the question?
It is more about the 6 gigahertz band, which is now
6 gigahertz.
licensed in US and many other countries.
Right. I think you know. Uh, Yeah, certainly public networks, public carriers will not generally not touch unlicensed bands. I mean, that's for very good reasons. So, but private networks may be more open to that, and therefore the unlicensed spectrum pieces of 5G allocation may be interesting. But currently, and I'm not entirely sure whether even for a private network, unlicensed bands is a good idea. At least example like in manufacturing or uh, where it's where it's safety and a lot of other criticalities, you don't control the spectrum and anybody can interfere. That might be too much of a risk. So so there may be many aspects of private networks which also have to have a license ban. So the CBRS band, which is the 3.55 to 3.7 gigahertz, 150 megahertz, that US is now licensed, or called lightly licensed, and it has, of course, the top tier is the Navy radars can use it without any problems, but then there's two layers below. I think the preferred the access layer and then the general access layers, and and they can use the band if they get some permission. So there's a database controlling it and so on and so forth. So this is a kind of quasi licensed band. I think this is where US a lot of talk of 5G or private networks, because there's some protection against interference, because you cannot transmit it without getting permission. And so I'm, there may be applications in unlicensed, pure unlicensed bands for 5G. I don't have much to say about it, but I think a lot of the current thinking of in US on private networks seems to be in the CBRS band, 150 megahertz.
Thank you. Second question is sort of follow up from a very lively discussion we had in the morning about 5G versus Wi-Fi and their role in the enterprise. And there was, kind of a, doomsday prediction from Victor Ball that, Wi-Fi will be dead in 5 years or 10 years. So I would like to seek your view on, what is the role of Wi-Fi, particularly given the way the Wi-Fi is evolving into a more cellular-like technology with 11ax, 11b. Does it still have a role to play in both the public Wi-Fi domain as well as enterprise?
Thank you. That's a very good question. First of all, of course, there's lots of terrible labeling of stuff going on. Like today, even though 4G has become 5G in US, 5GE, and Wi-Fi 6 has nothing to do with 6 gigahertz. I think it just means 11ax. So, yeah, so a lot of mislabeling. But Wi-Fi and I think cellular are very different animals, and I think both have the role to play. Uh, Wi-Fi being unlicensed is a fact that allows Wi-Fi to function in our homes and offices is because it's unlicensed. So that's critical. And and Wi-Fi also doesn't have a centralized control request grant. It's a CSMA CA type system. So all said and done, I think Wi-Fi is unlicensed. It's pervasive. It's cheap. It cannot inherently guarantee too much stuff because it is a CSMA type system where anybody can try and grab the channel. I mean, there have been attempts to improve it, but nevertheless, its DNA is different. The DNA of cellular is license band. It's centrally controlled. It's nobody can talk out of turn, and there's lots of mechanisms for tight scheduling. So, uh, uh, therefore, the cellular systems inherently can offer much higher guarantees of service quality, and of course, because also they're high power, they can be outdoors and therefore support mobility. Wi-Fi is low power. It can Lebanese can support some mobility, but it's not in the DNA. But on the other hand, it's really cheap and it's pervasive. So I think these are two different boxes, and I uh, because the cellular public networks will not go into unlicensed bands. It's only the private networks we could attempt that. Even there, I have my doubts. So I've got a feeling that Wi-Fi and cellular will continue to grow independently. There will be attempts like Qualcomm is making, others to try and get some more partnership between the two and more co-working. I still think they will sit on independent pillars because they are very different type animals with unique advantages in the pillars they sit in. So I doubt one will take over the other.
Right. Thank you so much. Maybe just until we get mics for folks to ask questions in the room as well. I have a sort of quick question for you, Professor Paulraj, which is, what do you think 6G or the next big wireless problems are going to be? Because I don't know if you if you can see the room, but we have like over 100 participants here, mostly PhD students. And so I'm really, I want to, on their behalf, I'm asking you, what are the problems that they should be focusing on?
Right. Yeah. I would, of course, somewhat tongue in cheek say, first of all, look at 5G and look at, all 5G's problems. I'm talking about now core technologies, of course. And so as 5G gets deployed, we're going to uncover issues that we don't like about it or need improvement. So that, of course, is the natural area for 6G. I would say, uh, uh, I mean, the 6G right now is lots of Zoom talks about it. Um, it probably take. I would first of all say that it must 6G must be developed on the foundation of 5G experience. It'll be unfortunate if we don't take 5G's experience into account. So that's going to take a little bit more time. So I hope 6G doesn't get too hardened too quickly. The other big elements in 6G, of course, is the role of AI. In 5G, uh, AI can, again, not too successfully so far. There's a lot of stuff going on, but deployment has been, I think, still low. You're using AI to enhance performance of 5G. So there's a lot of work going on. And of course, in 5G ORAN architecture, we already have this thing called the RIC, RAN Intelligent Controller, and with specific interfaces defined and so on and so forth. In 6G, I think it may be slightly little different in the sense that 6G will also be designed to enable AI, because AI will finally get more and more distributed or what's called federated, where the inference engines and the learning engines are dispersed spatially. So you got to, and there's enormous amount of data flowing between them, as you know. But within AI now, the model sizes are 2 and 3 trillion neurons. So building 6G to support a federated AI, I think, will be a big area. Other area I would say is satellite-based services. Um, uh, it to particularly two phones. There, the link budget is a huge problem, and we are nowhere near there today. Uh, and certainly, even this Starlink, which is becoming popular in the US, talks to a rooftop antenna. When you talk to a phone, we have a huge link budget issue. There have been some attempts today in 4G to do something about it, but I think 6G, 5G, 6G, I think will should pay more attention and really try and crack the problem of LEO satellite-based phone service. The reason for that is that it's a great equalizer. If that gets launched into space, then rural population, thin root population in our villages in India are not at disadvantage. They have as much access to to networks as somebody in the city, and so it's really an equalizing technology. But I think we need to do a lot more work to make that happen and make it cost effective. So satellite-based networks may be another area to look at. But I would still say there's a lot to learn in 5G. In fact, 5G is still really not deployed much. So that learning, particularly in the area of IoT and URLC, we'll find that the current solutions are not good enough, and we need to improve them. And also, about a couple of years ago, there was a seminar in Switzerland, which I gave a talk on, saying that lots of ideas were thrown up in wireless, but only some of them have gotten to standards, and many have not yet gotten to standards. And some of them, I think, are things like dirty paper coding, which I think is probably not needed because the way we do association and multi-user MIMO, um, network coding, um, a whole bunch of ideas which have not yet entered. Have been so far. In fact, some of them went into 3G and 4G and have been taken out now. So uh, uh, the question is, some of these orphan technologies, do they have a role to come back? And if so, how? That could be another 6G target. So I think there's plenty to be done in 6G for researchers. But I would advise PhD scholars to, uh, I know it's not easy, but to pay attention to standards, see what's going on in standards, because they represent the distillation of a lot of global thinking by people who are actually building this network. So they know where the shoe bites. So paying attention to standards and to see what the trends are there will be, I think, very valuable. And I still think in fundamental area, particularly in the PHY area, the way, for example, 5G is constructed, I don't think it can deal very well with, particularly in the millimetric band, with the microsectors, SSBs. It can deal very well with large angle spread multipath. So it's not properly set up for that. So it's lots of things which I think have to be improved. So pay attention to 5G, and I think there's plenty to be done in 6G. But also, I think for all over the world, and certainly in India, we should do a lot of prototyping. I think unless we prototype, we really never get to the bottom of things. So build stuff.
All right. Thank you so much, Professor Paul Raj, for all those insights. So now I'm going to throw the floor open for questions. Raise your hands. Whoever raises their hands first gets the mic. Um, yeah, before you get the mic, please introduce yourselves. I can't see who that is. Oh,
Maybe I'll just stand up so Professor Paul Raj can see me. Professor Paul Raj, good
Sure.
morning to you. What I wanted to ask was, nowadays there is a lot of talk about this open source software development for cellular networks, particularly 5G and maybe going forward. I was wondering, what are your thoughts on that? I mean, does it have a future, or how will it kind of impact the overall growth of 5G?
Right. I, you know, open source has turned out to be very successful in different businesses. In fact, I think a lot of software today is open source. The question is, does that model translate to infrastructure, 5G infrastructure? I think that's what we are really focusing here on. Uh, so um, I struggle with it. First of all, of course, there's lots of IP and there are 18,000 patent families in 5G. So, and that I'm sure can be sorted out. Um, and of course, 5G has a lot of mission critical or system or network critical functions, and therefore whatever software gets released has to be thoroughly checked. So and today in 4G and in 5G, there's lots of mechanisms for verifying compliance, and we have these test labs. So so open source will have to finally get to reality through all these current processes that we have. And pure open source is not that much funded. It's voluntary contributions. It works in some areas of software, but here where it needs very thorough testing, and of course certainly security is another aspect of it which needs a lot of testing and cleaning. Um, uh, it's not clear to me that the current model will be that successful. What sometimes happens is that a for-profit company which can invest money picks up the open source, like for example the Unix, Berkeley Unix, picks it up and then provides the support and infrastructure to make it acceptable. So that may be the way to do it. So what I say is, I think it's a great idea, uh, and I think a lot of students who build stuff there learn a lot. You actually make things work. So I think all power to it. But for final commercial deployment, all deployments are finally commercial. I think there's still organizational issues to be gone through. Uh, uh, the success of open source has been in different domains. In other domains, it's here. I think there are more challenges, and I think IP is one of them. Certification is another of them, and certainly the ability of people companies can invest money, and therefore will have to recoup it later by profits to bring this to the market. Is also another issue.
Right. Other questions? Okay. In the interest of time, I'm going to ask only one tiny question. Um, maybe so as 5G gets more international, right? There's natural questions about security. I think there's if you look at all the news around 5G, there are questions, accusations and counter accusations between different countries going on, right? So it's hard to figure out if this is just countries battling out for 5G supremacy, or is there some truth to those accusations, right? So this might be a kind of politically charged question, so you can punt it if you choose to, Professor Paul Raj. But what are your thoughts?
Well, well, yeah, it is a tricky area, but I think my general view is that a lot of the international tensions are more geopolitics. Um, with respect to inherent sensitivity of 5G, I mean, it is there in fact is in fact important point because 5G is going to touch a lot of machinery and vehicles and things if 5G is not reliable or if it is penetrated, hacked by malefactors, can create a lot of can create a lot of damage, danger, particularly to infrastructure. So it is obviously in a very critical core position, and therefore network security from various viewpoints is very, very important. And and I think I think there should be more international coordination to come up to try and come up with proper organizational support for this, so that everybody can verify that everything is correct, and and uh, and uh, and so right now, I think there's not much drive for cooperation on this front. So there's been some kind of some bifurcation happening in the world. I I think I think my opinion, 5G is security in 5G is particularly important. I think it needs international cooperation, and I hope that happens. Right now, it's not heading in the right direction.
All right. I think we are right at around 7:30. So I'd like to thank Professor Paul Raj and the wonderful audience here and all of the panelists who asked questions as well.